Hi, my name is Muhammad FAZLEY bin HANAPI. My matrix number is CE230098. So for now, I will make a presentation about question number 1, which is match the following equation and the expression. So for the first equation is like this. For the manual calculation is we can express like this. This is in spherical. Pi over 3 specify the angle from positive z axis in Cartesian coordinate 0 less than theta less than pi over 2. After we complete the manual calculation, we can conclude that the cone are symmetrical around z axis, forming an angle 60 degrees between two axes and surface of cone. So this equation is matching with the picture of C. C is the cone. For the for the simulation in MATLAB, firstly we need to define the parameter. We can produce a command like this. Which is for the first line is theta equal to least space negative pi, comma negative pi 100 is angular coordinate, and lean space 0, 100 is radial coordinate. Then we need to create a mesh grid for the parameter and define the cone of the angle of the cone, which is pi over 3. Calculate the z coordinate using the tan function. Convert from polar to Cartesian coordinate. Plot the cone for produce the figure for surface XYZ, and add the title and label. Like title is 3D cone, X label is X axis, Y label is Y axis, Z label is Z axis, and set axis equal to better visualization. And after we complete the MATLAB code, we can run the simulation. After run the simulation, we can get the output like this, which is we can get the perfect 3D cone in MATLAB if our coding is correct. Okay, this is our 3D cone. See, the figure is same like in the question. Okay. Next is question number 1b. Equation for 1b is r equal to 2 cos theta. For the manual expression, we can express the equation like this. Firstly, we need to find the Cartesian coordinate, and then we need to express r and theta using x and y. So we can conclude that the value of r, and then we can express r and theta using x and y to get the value of cos theta. So lastly, after we make a manual calculation, we can get, which is x minus 1 squared plus y squared is equal to 1. So we can prove that the equation of the circle in xy plane with center at coordinate 1, 0 with radius 1, the cylinder extends infinitely in both directions. So for this equation, this equation is matching with f. So as we can see here, f is a cylinder. So in MATLAB, we can open the code for f. Firstly, like usual, we need to define the radius and height of the cylinder. We can comment it like this. Then we need to generate coordinate x, y, z of a cylinder. Then we also need to scale the z coordinate to set the height of the cylinder. We also can shift the cylinder along the x-axis, x equal to 1. Plot the cylinder with color. figure, surface XYZ, face color, inter, edge color, and none. We can add title as like what we want. We can set the limit of axis and add the color map. After that, we can run the simulation. And we will get the 3D cylinder like this, and the figure of the cylinder is same like the figure in the question. So next is question 1C. For 1C, the equation is x square plus y square equal to z square plus 1. So for the manual calculation, we can express like this. We can express the xy plane, z equal to 0, xz plane, y equal to 0, zy plane, x equal to 0. So we can get the final answer like this. So from this, we can prove that the equation is matching with the figure D. Figure D is hyperbola. So in MATLAB, hyperbola is like this. Firstly, we need to define the parameter for vertical and angular parameter, and then we need to create the mesh grid for parameter. We need also to define the hyperbola equation. For ABC, A is semi-major axis, B is semi-minor axis, and C is vertical scaling. And we can define the equation here, and then we need to plot the hyperbola to get the figure out with mesh XYZ, H color, and R here means is for red color. If we want yellow color, we can set as Y, and we can add title like we want, and set the axis equal for a better visualization, and then we can run the simulation. After we run the simulation, we will get the surface of perfect hyperbola in the MATLAB, and as we can see, the hyperbola in our question is same like hyperbola in the simulation. So next is question 1D. 1D equation is y equal to x square plus z square. So for the manual calculation, we can find circle in xz plane with y over than 0. Second is as for increase, the radius of the circle increase, and the surface is parabolic. So the equation is matching with figure B. Figure B is this parabolic. So in MATLAB, we can get the figure of the parabolic. Firstly, like usual, we need to define the grid, and then define the equation of the paraboloid. And to create the plot, we can command like this: figure position 700, 100, 560, 420 to adjust the position to the surface. And then for surface XYZ, we can command as the H color, and this is none color. If we want the color, we can just put it as R for the red color. And then we can set as this limit for X is -2 to Y is 0, 8, Z and Z is -2 to, and we can label the axis for sorry, we can label the axis Y. X is X axis, Y is Y axis, Z is Z axis, and we can set the view. For my part, I set the view 120 and 30, and we can grade L and add color bar for the colorful output, and then we can run the simulation. And I get the output figure is like this, and it almost similar with this figure. Okay, next is for question 1E. The equation is like this. So for the manual expression is like this. Firstly, we need to find the Cartesian coordinate. x, y, z, and then after we get the coordinate, we can express z in terms of this, and we can express cos in terms of p, and we can get the square p. P square is equal to 2z, and then express p in the Cartesian, which is p square is equal to x square plus y square plus z, and after we make a manual calculation, the final answer is x square plus y square plus z minus 1 square is equal to 1. We can conclude here the center is 0, 1, 1, and the radius is 1. So for this equation, we can conclude that the equation is matching with figure A, and the figure A is here. For the simulation, firstly we need to comment as figure here to produce out the figure, and then we need to comment the subplot 1 to 1 to create a subplot for the first figure, and then we need to define the parameter for the sphere u, v, mesh grid, link space 0, 2 pi 30, link space, comma, link space 0 pi 30, and we need to put the equation of x, y, z and plot the sphere. And after that, we can run the simulation, and we will get the output figure for the sphere. And this is the output figure of a sphere that I get, and the output surface is same like in question. And lastly, for question 1F is z equal to x square plus z equal to x4 plus y4 minus 4xy. For without make expression, we can conclude that this equation is matching with E, and E is like this. This is a maybe paraboloid. Sorry if I am mistaken. Then the equation for E is like this. It's simulation. We can make a command like this, which is put the coordinate, put the equation of z, and this is a command to produce a figure, and then we can run the simulation. After the run simulation, I get the answer like this, but we can rotate the figure in 3D to get the maybe almost similar figure with the question. I can move it like this, and maybe like this to get almost similar figure like this. Next is question 2. Question 2 is below you are provided a sketch of the first quadrant of a part of level curve of some function f as y. Sketch the first octant part of corresponding graph, and this is the first quadrant. So we need to make a manual calculation. This is the calculation this is the manual calculation to get the output result. This is the figure after we make calculation, and this is on the fourth quadrant, and this is in 3D view. So in MATLAB, we can get the figure like that. This is firstly, we need to define the range of x and y. This is the range, and then we need to put the command of to create a mesh grid for x and y, and we need also to put a command for calculate the z values based on the given function, which is z is equal to 4 minus x minus y. We can put the command to create the surface plot for this is the for 3D. 3D we have x axis, y axis, and z axis. So we can, if we want 3D, we need to common as x, y, z. If we need 2D, we just common as s, y. And then we can add the label of a title s, y, z as like as we want. And we can add grid for a better visualization to get the best figure maybe. And then we can set the view angle for a better visualization for the best angle to see the output, and add the color bar, and then we can run the simulation. After run the simulation, I get the surface plot of 4 minus s minus z like this, and this is the perfect figure for me.
My name is Muhammad Amirul Hazeeq bin FAIZALIZAN. My metric number is CE230140. So today I will explain about question 3 and question 6. So firstly I will explain about manual calculation and simulation in question 3. In the manual calculation in question 3, we got for x equals 0, if x equals 0, the equation z equal fxy, and simplify to z equal 1 over y, giving the hyperbola yz equal to 1 for x equal to 1. Similarly, for x equal 1, if the function still provide the relationship z equal 1 over y, the equation yz equal 1 holds true. For x equal 2, again for x equal 2, the function giving z equal 1 over y ensure that yz equal to 1 means valid. So the general formula to show yz equal 1 for any x, assume fxy and identify that the surface indicates a hyperbolic relationship. So the form is z equal 1 over 5 is consistent with the level curve provided in the yz equal plane. So level curve for any fixed x, z and y must be satisfied yz equal 1. So the summary, based on the provided graph and the surface shape, the level curve for z equal fxy suggest a hyperbolic relationship consistent with yz equal 1. The conclusion is we know the equation is yz equal 1 because this analysis justify the conclusion that the equation describing the level curve is yz equal 1. So that's a manual calculation for question 3, and then I will show about the simulation. So and then this is the simulation for question 3, and this is a coding. So firstly define the range for y and z values, and then generate grid of point in the yz plane, and then calculate corresponding x value based on the equation yz equal 1, and then put the coding for plotting the level curve, and then define the domain x and y values, define your function, replace with your own expression, create the surface plot, and then we got the graph like that. So figure 1 we got level curve for yz, and then we got 3D surface plot. So that's for question 3. Now I will explain about question 6. So in question 6, the manual calculation for question 6 fxy equal e power of negative x power of 2 plus 4y power of 2. And then let the fxy equal to k. And then we got e power of negative x power of 2 plus 4y power of 2 equal to k. And then we got, and then we put k to ln k. And then we assume k equal 0.1, 0.5, 1, 2, and 5. Sorry, I forget to put 2 and 5 here. So, and then we calculate ln 0.1, ln 0.5, ln 2, and ln 5. And then after we got the answer, so I got a contour map like that, like this. So that's all for manual calculation for question 6. And then I will want to show about the simulation for question 6. And then this is coding for question 6. Firstly, define the function.
Hi and a very good day to Cikgu Xavier. So my name is FITRI bin ALIAS. My metric number is CE230052. So for my part is to do question number 4 and number 5. So for question number 4, sketch some of the level curves of f x y equal to x square plus 2y. So this is for manual calculation for question number 4. So we do x square plus 2y equal to c. C is the constant. And I put the value of c is 0, 2, 4, 6, and 8. So for number 1, we put the value of 0 equal to x square plus 2y. So we get x0 and y0. And number 2, we use value 2 over 2 equal to x square over 2 plus 2y over 2. So 2 over 2 is 1 and equal to x square 2 over 2 plus y over 1. So for a is equal to power of square of 2 equal to, we get 1.4, and for b we get 1. And number 3, we use value of 4 over 4 equal to x square over 4 plus 2y over 4. And 4 over 4 is 1, and x square over 4 plus y over 2. So for a we get 2, square of 4 we get 2, and for b square of 2 we get 1.4. And for number 4, we get for a is 2.45, and b we get 1.73. And then for number 5, so 8 over 8 and x square over 8 plus 2y over 8. So we get 1 equal to x square over 8 and plus y over 4. So we get a is 2.82 and for b is 2. So this is for the sketch level curve. So this is for number 1 is x0 and y0. So this is for x 1.4 and y is 1, and this is for x2, y 1.4. And then for number 3 is 2.4, x is 2.45 and y 1.73. And for number 4 we get x 2.82 and y is 2. So for the coding, we define the function of the question fxy equal to x squared 2 plus 2y squared 2, and then we define the range of x and y values. So for x line space, we use -4, 4 and 400, same to y. And then for calculate the function value for the mesh grid, and then we define the level curves we want to plot. The value we use from the manual calculation, so we put 0, 2, 4, 6 and 8. And then for plot the level graphs, we label for x label is x and y label is y. So and then for this is the graph, same to quantum map, the graph we get from the MATLAB for question 4. So this is for question number 5, is sketch the level curves of fxy equal to 2y over x squared plus y squared. And then for fxy, we change to k equal to 2y x over x squared plus y squared, and then 2y equal to k x squared plus y squared, and 2y equal to k x squared plus ky squared, and we get kx squared plus ky squared minus 2y equal to 0. So this is quadratic equation that we know for A is k, and B is -2, and C is kx squared. And we use the formula is -b plus minus square root b squared minus 4ac over 2a. So for the first one, y equal to minus and -2 plus minus -2 square minus 4 multiply k and multiply k x square over 2k. And then so the last we get y equal to 1 plus square root 1 minus k square x square over k. And then for the second one, y equal to 1 minus square root 1 minus k square multiply x square over k. And for the first one, for k1, so we put the value of 1 into k. So we get for the plus, we get equal to 1 plus square root 1 minus 2 x square, and for the second one, 1 minus square root 1 minus x square. So for the semicircle, enter at 0, x 0 and y is 1 with radius of 1. And for the value of k, we use 1, 0.5, negative 0.5 and negative 1. And for k 0.5, we get 2 plus 2 square root 1 minus 0.25 x squared. And the second one, we get 2 minus 2 square root 1 minus 0.25 x squared. So for the semicircle, enter at, for x is 0 and y2 with radius of 2. And for k negative 0.5, we get negative 2 minus 2 square root 1 minus 0.25 x squared. And the second one, we get negative 2 plus 2 square root 1 minus 0.25 x squared. And for the semicircle, enter at for x 0 and y negative 2 with radius of 2. And for the last one, for k negative 1, we get negative 1 minus square root 1 minus x squared. And the second one, negative 1 plus square root 1 minus x squared. So the semicircle, enter the x is 0 and y is negative 1 with radius of 1. So this is for the sketch the level curves of this equation. So for the coding in MATLAB, so this is for the coding in MATLAB. First, we define the function and from the equation, and then we create a grid of x and y values. For x length space, we use negative 5, 5 and 400, same to y. And we define the level curves, the level values from the manual calculation, and we use negative 1, negative 0.5, 0.5 and 1. So this is the 2D level curves of this equation for question number 5. Hi and a very good day to Cikgu Xavier. So my name is Ahmad FITRI bin ALIAS. My metric number is CE230052. So for my part is to do question number 4 and number 5. So for question number 4, sketch some of the level curves of f x y equal to x squared plus 2y. So this is for manual calculation for question number 4. So we do x squared plus 2y equal to c. C is the constant. And I put the value of c is 0, 2, 4, 6 and 8. So for number 1, we put the value of 0 equal to x squared plus 2y. So we get x0 and y0. And number 2, we use value 2 over 2 equal to x squared over 2 plus 2y over 2. So 2 over 2 is 1 and equal to x squared 2 over 2 plus y over 1. So for a is equal to power of square of 2 equal to, we get 1.4, and for b we get 1. And number 3, we use value of 4 over 4 equal to x squared over 4 plus 2y over 4. And 4 over 4 is 1, and x squared over 4 plus y over 2. So for a we get 2, square of 4 we get 2, and for b square of 2 we get 1.4. And for number 4, we get for a is 2.45 and b we get 1.73. And then for number 5, so 8 over 8 and x squared over 8 plus 2y over 8. So we get 1 equal to x squared over 8 and plus y over 4. So we get a is 2.8 2, and for B is 2. So this is for the sketch level curve. So this is for number 1 is x0 and y0. So this is for x 1.4 and y is 1, and this is for x2, y 1.4, and then for number 3 is 2.4, x is 2.45 and y 1.73, and for number 4 we get x 2.82 and y is 2. So for the coding, we firstly define the function of the question fxy equal to x squared 2 plus 2y squared 2, and then we define the range of x and y values. So for x, linear space, we use -4, 4 and 400, same to y. And then for calculate the function value for the mesh grid, and then we define the level curves we want to plot. The value we use from the manual calculation, so we put 0, 2, 4, 6 and 8. And then for plot the level graphs, we label for x label is x and y label is y. So and then for this is the graph, same to quantum map, the graph we get from the MATLAB for question 4. So this is for question number 5, is sketch the level curves of fxy equal to 2y over x squared plus y squared. And then for fxy, we change to k equal to 2y x over x squared plus y squared, and then 2y equal to k x squared plus y squared, and 2y equal to k x squared plus ky squared, and we get kx squared plus ky squared minus 2y equal to 0. So this is quadratic equation that we know for A is k, and B is -2, and C is kx squared. And we use the formula is minus b plus minus square root b square minus 4ac over 2a. So for the first one, y equal to minus and -2 plus minus -2 square minus 4 multiply k and multiply k x square over 2k. And then so the last we get y equal to 1 plus square root 1 minus k square x square over k. And then for the second one, y equal to 1 minus square root 1 minus k square multiply x square over k. And for the first one, for k1, so we put the value of 1 into k. So we get for the plus, we get equal to 1 plus square root 1 minus 2 x square, and for the second one, 1 minus square root 1 minus x square. So for the semicircle, enter at 0, x 0 and y is 1 with radius of 1. And for the value of k, we use 1, 0.5, negative 0.5 and negative 1. And for k 0.5, we get 2 plus 2 square root 1 minus 0.25 x squared. And the second one, we get 2 minus 2 square root 1 minus 0.25 x squared. So for the semicircle, enter at for x is 0 and y 2 with radius of 2. And for k negative 0.5, we get negative 2 minus 2 square root 1 minus 0.25 x squared. And the second one, we get negative 2 plus 2 square root 1 minus 0.25 x squared. And for the semicircle, enter at for x 0 and y negative 2 with radius of 2. And for the last one, for k negative 1, we get negative 1 minus square root 1 minus x squared. And the second one, negative 1 plus square root 1 minus x squared. So the semicircle, enter the x is 0 and y is negative 1 with radius of 1. So this is for the sketch the level curves of this equation. So for the coding in MATLAB, so this is for the coding in MATLAB. First, we define the function and from the equation, and then we create a grid of x and y values. For x length space, we use negative 5, 5 and 400, same to y. And we define the level curves, the level values from the manual calculation, and we use negative 1, negative 0.5, 0.5 and 1. So this is the 2D level curves of this equation for question number 5.
So we got a contour map like this, same as manual calculation in question 6. So that's all from me. Thank you. Now I will send to the next presentation.
It's RAZITA BINTI RAZLAN and my metric number is CE210014. So for the question 7 here, the task is to sketch several level curves where z is constant. So first, we must simplify the given equation to make it easier to calculate. The equation is x to the power of 2 plus y to the power of 2 minus z to the power of 2 plus 2z equal to 0. We can rewrite this equation in the form x to the power of 2 plus y to the power of 2 equal to z minus 1 to the power of 2 minus 1, which simplifies to r equal to square root z minus 1 to the power of 2 minus 1. Next, we use 4 layers to complete the surface. We assign the z values as follows. So the first layer is we give the value 3 for the z, and the second one is 5, the third layer is 7, and the last layer is 9. We substitute each z value into the simplified equation. For the first one is z equal to 3, so the answer is square root 3. The second one is z equal to 5, and the answer is square root 15. The third one is z equal to 7 and the answer is square root 35, and the last one is z equal to 9 and the answer is 3 square root 7. So from this calculation, we obtain the radian for each layer is square root 3, square root 15, square root 35 and 3 square root 7. Using this value, so we can draw each layer to create the level curves as shown here. So next, we need to draw a rough sketch of the surface. As we can see, the equation represents a hyperboloid. We use the previous equation and insert the z values as shown in the table to get the r values. From these results and the level curves we have done before, we can imagine and draw the surface in 3D sheet. Next, for the simulation, we use MATLAB software as you can see on the screen. For the coding, we write part A for question A and part B for question B before starting the simulation. In this coding, we must use divided commands to give exact instructions so the software can read them properly. We also specify the values of z, which are 3, 5, 7 and 9. After that, we use the figure command to pop out the first result. To complete the result, we must write the equation the same way as in the manual calculation so we can get a similar answer. We include all plotting commands like x level, y level, grid and etc. to ensure the answer pops out correctly in the simulation. To complete the instruction in the coding, we use bulldog to let the software know we have finished the question. Here is the result. As we can see, the answer from the manual calculation and the simulation are the same. This means our answer is correct.
Question 8. Sketch the hyperboloid z square equal to 4x square plus y square minus 1. So, first thing first, we need to make a manual calculation to get the plot of the hyperboloid. And this is the step to get the plot. Firstly, we need to find z equal to 0 for xy plane. And this is the equation. And we get the answer is y equal to 1, x equal to 0.5. And this is, if we set z equal to 2 for xy plane, and after manual calculation, we get the coordinate of x is 1.12, z is 2.24, and as x equal to 0, yz plane is like this. Is y square over b square minus z square over c square is equal to 1. And this is the sketching for axis y and z, and this is the 3D sketching. For the simulation, firstly we need to plot the upper half of the hyperbola. We see figure semicolon mesh x, y, z, h color. I choose red color because I like red color. And then we will start from the up. Firstly, we can define the parameter for x and y, which is sy mesh grid list space -2, 2, 50 list space -2, 2 and 50. And then we can compute z from the hyperbola of equation. Equation is from the question. Z square is equal to 4x square plus y square minus 1. And this is the common for upper half hyperbola and lower half hyperbola. We can set invalid point for incomplex number. And this is plot for upper hyperboloid. Set color, I choose red because I like red. And this is plot for half of the hyperboloid. And I also choose red, but if you want to make the half color is red, half color is yellow, I can make it. I change the red color to yellow color, and add title label like usual, and set as equal for a better visualization, and then we can run the simulation. and this is my hyperboloid. This is 3D hyperboloid. It is also similar with the manual calculation.
For question 9, the task is to describe the level surface of f x, y, z equal to x to the power of 2 plus y to the power of 2 plus z to the power of 2. This equation represents different geometric shapes depending on the value of c. So the first one, for c more than 0, so the level surface is a sphere centered at the origin 0, 0, 0 with a radius of square root c. For the second one, for c equal to 0, the level surface is the degenerate sphere, which is just single point at the origin. For the third one is for c less than 0, so there are no real solutions for x, y, z because the sum of the squares of real numbers cannot be negative. Hence, no level surface exists for negative c. We can directly use MATLAB for the 3D drawing. As seen in the coding, we give direct instructions such as the grid ratio and the desired color. In this case, I let the software choose a random color. After inserting the instruction, we label all necessary information such as the x-axis, y-axis, etc. to complete the drawing. Finally, we use hold off to finalize the plot. Here is the result that we obtained from the simulation. Thank you.
Very good morning to my respectful lecturer. My name is KATHIRVEL ARMUGAM from Section 1, Group 6, Matrica number CE 230159. Today I am going to explain about question 10. So first we see the question 10. The question 10 is FC y equals to sine x. They are asking sketch the graph for this range x 0 to 2 pi and then y equals to 0 to 1. So we already know the x-axis and y-axis value. So we straight away sketch the sine wave because they already say it's a sine graph. So now we see the MATLAB coding. This is the MATLAB coding. These are the coding. First we define the range of the x. These are the one, and then this is the question to compute functioning value. So create a 2D plot in figure. So it will be out, the output will be come out like a figure and then the sine graph. So plot x and y, and then label the axis. X label equals to x, and then y label equals to sine x, and then add the title upper one 2D plot of fx equals to sine x, and then set the axis limit for the better visualization. So x line is 0 to 2 pi, and then y equals to 0 to 1. Just now we see in the question. So I insert the coding over here, and then add the grid better and visualize. We are adding the grid, and then set the axis stick x stick to the 0 pi over 2 to pi. So x-axis label 0 pi slash 2, and then 2 pi, and then 3 over pi over 2 pi, and then add the y tick to show the range 0 to 1. So it will be tick the range lah, the y-axis 1 range. So now we are going to generate the coding. If we generate the coding, it will be come out like this. Yeah, these are the one. So it's showing the sine graph. The x-axis 0 to 2 pi, and then the y-axis is 0 to 1. So the sine wave is going to the x value 1 and then come down to 1 again lah, and then the x value 0 to 2 pi. So this is 1 cycle, and this is the sketch graph for the question 10. I'm going to explain about question 11. Question 11, they are asking sketch and describe the following surface. So question is x square plus y square plus z square equal plus 4x minus by plus 9z minus b equals to 0, where b is a constant. So we already know b is a constant value. So we see the calculation for x. So we just take the x value only. So x square plus yx equals to x plus 2 square minus 4. So we just change into this form, and then y equals to y square minus by equals to y minus b over 2 square, and then minus b over 2 square, and then we go to z. Z square plus 9z equals to z plus 9 over 2 close bracket square minus 9 over 2 square. So now we just substitute this value in this form. So we just substitute the value, though, so the equation will be open bracket x plus 2 close bracket square minus 4 plus y minus b over 2 square minus b over 2 square plus z plus 9 over 2 square minus 9 over 2 square minus b equals to 0. So we just separate the value. So we just take the x, y, z, the square value all on our left side, other value all in right hand side. So x plus 2 square plus y minus b over 2 square plus z plus 9 over 2 square equals to b plus 4 plus b square of b over b square over 4 plus 81 over 4. So we just expand this value. So we just 9 square equals to 81, 2 square equals to 4. So we just expand the value lah. So now we're going to find the radius. The radius is b plus 4 plus b square over 4 plus 81 over 4. So now we going to determine the value of the b. So b equals to 4, and then 16 plus b square plus 81 over 4. So we just same the value of the denominator, and then 997 plus b square over 4 plus 4b, and then 97 over 4 plus b square over 4 plus 4b over 4 equals to 97 plus b square plus 4b over 4, and then r square equals to 97 plus b square plus 4b over 4. So now we're going to simplify, and then we take the square, and then we move to the right hand side. So it will be square root b square plus 4b plus 97 over 2. So I just take the over 2 as a 1 over 2. So the center of the sphere is a 1 over 2. Open bracket negative 4 b negative 9 plus 2 rb. So these are the spheres that I sketch, and then now we're going to see the MATLAB coding. Yeah, this is the simulation, the MATLAB coding. First we insert the b value. B value equals to, just now I say in the calculation, b value is equals to 4, and then compute the radius r based on the value of the b. Just now we saw the r value, r equals to square root 1 over 2 square root b square plus 4b plus 97. So over 2 it will be come in front of 1 over 2, and then create a mesh grid for the period, and then pi. So we just make the grid for that, and then line space 0 pi 50. So it will be show the 0 pi 50, and then pi li space 0 2 pi 50, and then mesh grid and then pi, and then parametric equation for the sphere is s equals to r times sine times cos minus 2. These are the basic formula for the sphere, to construct a sphere. So I just insert the value as a coding. So plot the sphere. It will be come out with a figure, and then x, y, z, x value, y value, z value, and then x will be labeled as x, Y is will label as a Y, Z will be labeled as a Z. And then the title will be sphere for B equals to 4. So the grid on, so it will be shown in a grid, and then display the center and then radius of the sphere, and then these are the coding for to display the radius lah. So these are the output. This is a sphere. The sphere. This is a title sphere for B minus 4, and then this is the Z value, Y value, and then this.